हेलो फ्रेंड्स, आपने मेरे थर्मल साइंस के लेक्चर्स देखे होंगे, रेफ्रिजरेशन पे लेक्चर्स देखे होंगे, फ्लूइड मैकेनिक्स पे लेक्चर्स देखे होंगे। मोर ओवर इंस्टीट्यूट फॉर मैकेनिकल इंजीनियर्स की दूसरी फैकल्टीज़ के आपने स्ट्रेंथ ऑफ मटेरियल, थ्योरी ऑफ मशीन, मशीन डिज़ाइन एंड मटेरियल साइंस के भी लेक्चर्स देखे होंगे। And upon the request of several students, they have asked to form the lectures of industrial engineering and operational research. So for the sake of those students as well as other students, now I am delivering the lecture on the first topic of industrial engineering, the linear programming. Fine. Now let us understand what is linear programming. See students, linear programming क्या है? First of all, we must understand what is programming. Now see, programming is nothing but a mathematical technique. It is a mathematical technique, and if we together consider this linear programming, so we can define it as a mathematical technique for optimization of our objective function subject to some constraints and non-negativity restriction. And the condition being that this objective function and constraints, these objective function and constraints must be linear. Now what do we mean by linear? For example, there is equation 5x plus 6y is equals to 45. Now see students, here the power of this variable is 1 and here the power of this variable is 1. So we can say it as a linear equation. We can call it as a linear equation. Fine. As the name suggests, linear programming, our objective function and constraints must be linear in nature. Now let us understand what do we mean by this optimization word. What do I mean by this objective function? What do I mean by this constraints, and what do I mean by this non-negativity restriction? Now let us come to optimization. What is optimization? Optimization is nothing but efficient use of resources. Efficient use of resources for maximization of profit, or we can say minimization of cost. Is it okay? So we have several resources. For example, manpower is a resource to us. For example, the machinery is resource to us. We should use them so much effectively that our profit is maximized or our cost is minimized. So we see that the resources with us are of 4 types. The first one is your manpower. The second one with us is your machine. The third one is our raw material, and the fourth one is our infrastructure. These are the resources, we need to use them so effectively that our profit is maximized or our the cost is minimized. Is it okay? Fine. Now see students, let us understand the meaning of our objective function, constraints and this non-negativity restriction with some example. Fine. Suppose there is a company which manufactures two products, product A and our product B. Fine. And let the number of units manufactured of product A be our X1 and the number of units manufactured for product B be X2, and the profit earned per unit of selling of product A be suppose rupees 3 and for 1 unit of B let the profit be 4. Fine. So what we can say is that our objective function, what will be our objective function? To maximize profit, and let this objective function is represented by some variable z. So our objective function can be written as maximize z equal to 3x1. Why 3x1? Because for 1 unit of A the profit is 3. So for x1 units the profit will be 3x1. Similarly for x2 units of V the profit will be 4x2. So this becomes our objective function. Fine. Now let us move to constraints. See, as the name suggests, constraints means the limitations with us, and the limitations might be of machinery, might be of manpower, might be of infrastructure, or might be of raw material. Is it okay? Now let us see. Suppose product A requires iron as well as copper. It requires iron as well as copper. Suppose for 1 unit of product A we require 1 kg iron. Fine. And similarly we require 2 kg copper. Now for product B, suppose for 1 unit of product B I require your 1 kg of iron and 1 kg of copper, and the total iron available with us is suppose 450 kg, and the total copper available with us is suppose 600 kg. Is it okay? So how to write our constraints, or we can call it as limitations. See, the constraint with us is that we cannot exceed the iron amount by 450 kg. Fine. So for 1 unit of A we required 1 kg. For x1 units we will require 1 into x1 kgs. So we can write the constraint like this: 1 into x1 plus 1 into x2 will be less than equal to our 450. 450 is nothing but total amount of iron. Similarly for copper we can write 2 into x1. 2 into x1 plus 1 into x2 less than equal to 600. So these becomes our constraints. And the last thing we must know is our non-negativity restriction. The non-negativity restriction. What do we mean by non-negativity restriction? See students, first of all understand that here this x1 and this x2, these are our decision variables. These are our decision variables. That means we need to find the value of x1 and x2. That means the number of units produced of product A and the number of units produced of product B. We need to find the value of x1 and x2 such that our profit is maximum. So that's why they are known as our decision variables. Fine. And non-negativity restriction means that our decision variables x1 comma x2 must be greater than equal to 0. See students, why it must be greater than equal to 0? See, x1 is the number of units produced for unit A, x2 is the number of units produced for product B. Is it okay? Either the company will manufacture them, either the company will manufacture product A or B, or they will not manufacture product A and B. If they manufacture, then x1 and x2 will be greater than 0, and if they don't manufacture, x1 and x2 will become equal to 0. But the value of these decision variables can never be negative. Is it okay? Fine. Now see students, here this 450 and this 600, these are known as our resource values. The total resource of iron is 450 kg, the total resource of copper is 600 kg. So these are known as our resource values. Fine. And see students, this one, this two and this one, these are known as our technological coefficients. These are known as our technological coefficients. Fine. And see students, here this 3 and this 4, this 3 and this 4, these are nothing but our profit coefficient. These are known as our profit coefficient. This is nothing but the profit by selling 1 unit of product A. This is the profit by selling 1 unit of product B. And if the problem is that of minimization type, if the problem is that of minimization type, these are known as our cost coefficient. These are known as our cost coefficient. Fine. See students, we have formulated this problem earlier here on the board. Fine. Now we will try to write a generalized form of linear programming problem. The generalized form of linear programming problem. Fine. So first of all, we need to write our objective function. So objective function will be our maximization or either minimization of our objective function, and In general form, it can be written as C1 x1 plus C2 x2 plus Cn xn. That means we have n number of decision variables. We have n number of decision variables, first, second, third, fourth up to n. Similarly, we have n number of cost coefficients C1, C2 up to Cn. So we have n cost or profit coefficients. Is it okay? Now this was our objective function. Now we need to represent our constraints. So it is represented as subject to. The first constraint is written as A11 x1 plus A12 x2 plus A1n xn should be less than equal to B1. The another constraint A21 x1 plus A22 x2 plus A2n xn less than equal to our B2. Similarly, if we consider that we have m number of constraints, so the last constraint can be written as am1 x1 plus am2 x2 plus amn xn less than equal to bm, where this m is nothing but the number of constraints, or it is also nothing but equal to number of resource values B1, B2 up to Bm. So it is nothing but equal to number of resource values. Is it okay? And then at the last comes your non-negativity restriction. So non-negativity restriction we can write x1 comma x2 comma x3 up to your nth decision variable xn must be greater than equal to our 0. Is it okay? Fine. Now see students, here this one, the first one in the subscript represents your row, where the second one here represents your column. Is it okay? Fine. Now see students, here the row is represented by I, the column is represented by j. The row is represented by I and the column is represented by j. Is it okay? So we can write our technological coefficient, these A11, A12, A1n, like Aij, where I represents your row and j represents your column, and where I varies from 1, 2, 3, 4 up to m, 1 to m, and your j varies from 1, 2, 3, 4 up to n. So j varies from 1 2n. Is it okay? This becomes our technological coefficient. Fine. Now see students, how to represent our cost coefficient. Cost coefficient. See, C11, C1, C2, Cn are our cost coefficient. So it is simply represented as Cj. See, J represents your number of columns, and how many number of columns? First, second, third, up to n number of columns. So here we can represent J varies from 1 to n. J varies from 1 to n. Then how to represent our decision variables? Again, how many decision variables? 1, 2, up to n. So it is represented by again xj, where j varies from 1 to n. And then how to represent this resource values? See, these resource values are represented by b. So here resource values are represented by B. And how many resource values? 1, 2, 3 up to m. And m are nothing but number of rows. And the rows are represented by I. And here the I is varying from 1 to m. I is varying from 1 to m. And the last one, technological coefficients are represented like this. Fine.